Okay, so let's put some of these pieces together as we talk about using the drill press in an actual project. And what's going on here is I'm building a piece of testing equipment, and it involves this hydraulic cylinder right here. And it involves mounting it to this large frame, this piece of I-beam. And so what I'd like to do is I'd like to carefully measure and mark out where these holes are in the cylinder so that I can mount it to the I-beam. To do that, I'm going to use some of my measuring tools. My preferred choice is going to be a pair of calipers, but then since some of the holes are too far apart, I'm going to have to use a ruler for that. Now to find the centers of these holes, I can eyeball it. That would look something like this. I would hold the calipers up, and I would try to get them as close to the centers of these holes as possible. But a better way to do that involves just a little bit of math. I take these and I measure from the inside edge to the inside edge, like this. And then if I flip them and I use the back jaws and I measure from the outside edge to the outside edge of those holes, I can average those two readings and I can figure out where the exact center to center is. Think about it. The center is the average of the inside edge and the outside edge. So if I measure outsides and insides, I can get that. Now, unfortunately, for the length between the holes, I had to go back to eyeballing that with a ruler here because I don't have a pair of calipers long enough to do the other trick. So I did that already. And then what I did is using a scribing tool and the same measuring tools, I marked out the positions of those holes on the I-beam. And this might be a little bit hard to see in the camera. I've marked out some other holes here as well. You can see just those scratch lines in there to indicate where the holes are. So what I'm going to do is I'm only going to drill the 4 for the hydraulic cylinder right now. Now, just having those scratch lines there is not quite enough because the drill bit's going to want to come down, and I want to make sure that it finds that exact spot. So I'm going to grab a center punch and a ball peen hammer. And I'm going to line up the center punch right on one of those crosses and give that a good tap. And that'll create kind of a crater or a little divot right there to help the drill bit find the right spot. In fact, in this case, I'm actually going to follow on with a drill called a centering drill. It's just this little stubby piece of drill like this. And that's going to help me get an even better starting hole because this piece of I-beam here is kind of big and it's going to be a little bit hard to wrestle underneath the drill press. So this makes it easier because I'm getting an even bigger starting hole for each of those 4. In fact, at this point, it's a good idea to measure again and double check and make sure that we're getting what we expect. So I'm going to drop the calipers in here the best I can. And verify that we're getting the distances that we need. In fact, it's not a bad idea to even put that hydraulic cylinder over and just kind of have a reality check. Are those ending up where we thought they would be? Like that. And sure enough, they are. So we'll move this over to the drill press. Now, eventually what I do want to do is I want to drill those to fit a 3/8 inch bolt like this, because that's the size that I have for the hydraulic cylinder there. It's going to actually work better if I don't do that all in one step. So I'm going to reach towards my set of drills here. I'm actually going to drill a 1/4 inch hole first, and then I'll follow along with the 3/8. That'll make it easier for the drill press. It doesn't have to work as hard. Okay, so there are the 4 holes drilled with the 1/4-inch drill bit, and we're going to follow those on with a drill bit slightly larger than 3/8 of an inch. So the set that I have here comes in all kinds of different sizes. And if I wanted that hole to be very, very tight, I'd pick a 3/8 inch drill bit right here. But instead, I'm going to go 1/32 of an inch larger than that. I'm going to go to 3/32 right here. Slow down my drill press because I'm using a larger drill bit. And it turns out that it's actually faster to drill the small hole and then the large hole than it is to just try to drill the large hole all at once. So that second one went quite a bit more quickly. All right. So let's take that back off the drill press, move it over to the table here. Now, one of the things about when you drill through metal is you'll get what are called burrs on the bottom of the holes. So you can see somewhat in there. Those holes aren't really clean. They have a little bit of metal that's broken out the other side. So what I'd like to do is take my cordless drill again and switch out for a tool that looks like this. This is called a countersink, and those 45-degree angles there are perfect for cleaning up the burrs that are on the outside of the holes. And whether that comes across in the camera again, kind of hard to tell. What I've done is put a beveled surface, kind of a 45-degree angle on the edge of that hole, which cleans up all those little bits, gets much more professional appearance. And I'll follow that along. I'll do that on the starting side too. Okay, now let's see what we got. Let's see if we can drop that hydraulic cylinder on here with the bolts through it. Let's see how it looks. So I've got 3 and 4. There we go. Looks like they all fit through, no problem. This is going to have to come off several more times, and so I'm not going to tighten these for good, but just so that I don't have this loose and flopping around. Here's what I'm going to do. I'm going to take this and bring that up here, and grab a ratchet wrench. Also going to grab my cordless drill with the socket for that size bolt right there. Let's throw this together. Something like that. leave it at that one. There we go. That's what we're looking for. Bolts coming through the other side like that. And we'll continue on with the rest of the measurements and the machining on this testing machine.